everyone. Hello, everyone. Welcome to the new webinar. Today, webinar is about like unlocking high performance of Postgres, and it's more about like the key settings whenever you are going to start your Postgres. And so, before start, some key, most of the key parameters and most of the best strategies to make sure that your Postgres will be running properly and it's up to the standards and it's up to the market best practices. So that is something we are going to discuss today. I will be like presenting this presentation to you and my co-presenter, which is Warda. So thank you so much for joining, guys. Yeah, next.
Thank you, Mughees. So before my colleagues go ahead and dive right into it, let me go over a few housekeeping items. This webinar is being recorded and the recording will be shared with you afterwards. If you have any questions for our speakers, we are going to have a Q&A segment at the end. Please feel free to either use the Q&A feature or the webinar chat box. And yeah, that's it from my end. Over to you two.
Thank you. So about me, my name is Mughees Ahmed, and I'm a Postgres consultant at Stormatics. I started my career back in 2017 from Zong, which is the telecom company, and then after that, I continued to start working. I mean, continue to work on it still in the telecom sector, which is like it is Solcom. It was based in Bahrain, and then I moved to Percona, which is like Percona is like a performance consultant company for the MySQL and the Postgres. And then after working there, I'm working as Stormatics as a Postgres consultant. And next, Varda, please. So about today's agenda, what we are going to do is that we will be talking about the key parameters, which are like mostly related to the Postgres. As I mentioned earlier, that whenever you are going to install your Postgres, you need to make sure that you have few parameters in your buckets that you need to make sure that you have set them up to the standard market or the best practices which have been followed by most of the engineers throughout the years of the Postgres. So the most and the prominent is that obviously it's always the shared buffer, which is like a memory for the database, and then we have the workman, which is like the memory for the sessions and all that, and the processing which a session is doing inside any operations, like the queries and the sort operations and all that, and then we have maintenance work memory for the maintenances and of the objects of the databases, and then max connections, effective cache sizes, and one of the most key operation in Postgres performance, which is like checkpointing. And so why like checkpointing? We have mentioned like max file size and background writer and checkpoint segment. These three are the parameters which you always work on them together, and that's why we have like kept them under checkpointing. So whenever you want to like tune your checkpointing, you need to make sure that you touches all of three of them. And after that, we have auto vacuum tuning, and then it's like there are a bunch of like 10 parameters which we are going to touch, that make sure that if you have all these three segments touched in your Postgres, that I believe that 80 or 90 percentage of your Postgres will always be tuned properly. And then these are the first thing, and after that obviously it depends on the workload, how your workload is going, and then based on that workload you can tune your parameter accordingly. Next, please. uh yeah, thank you, Varda. Continue to you.
Thanks, Mughees. Hi, everyone. I am Warda. I'm a Postgres consultant. I started my journey as a web development intern at security. In 2024, I joined 99 Technologies. There, I worked mainly on backend engineering, performance, automation, and backups. In 2025, I joined Stormatics as a Postgres consultant. Here, I specialize in Postgres internals, performance tuning, optimization, and I also work with HA and DR architectures. I'm also an active contributor to the Postgres community through technical blogs, guides, and patch reviews. As Mugees mentioned, today we'll be sharing practical insights based on what we have seen in real production environments, and we hope that you find them useful for your environments. So let's start. So this is the Postgres architecture of the holistic overview. We will come back to this after we understand the individual components that we are going to do right after this. So let's circle back on this. Um, in basic configurations, the first and most important parameter that we have in Postgres is shared buffer. In this architecture diagram, you can see that whenever a Postgres backend issues a request, be it read or write, let's say if it is a read request, Postgres never directly takes data from the disk and send it to the client. Instead, it will first load data into the shared memory and then it will return to the client. And the same idea applies to writes as well. When a client will modify the data, Postgres won't immediately write those changes to disk. Those changes will first load it into shared buffer, shared memory, modified in RAM, and these will marked as dirty pages, which means that they'll later flush onto disk. And this design of first loading data into the shared memory is intentional because reading from and writing to memory is much faster than disk, and this will reduce I/O overhead. Now, this shared memory area that I'm talking about, this is managed by shared buffers parameter in Postgres. All the reads and writes go through this shared buffer. We can only read from shared buffer and we can only write to shared buffer. Disk interaction don't usually happen directly with the client. It will happen later on asynchronously in the background. So you can think of shared buffer as a layer between disk and backend process. And by default, the value is 128 MB, which is typically very low for the production environments. So this definitely should be tuned. And the question is that how do we size it depending on the workload? For this, a common rule of thumb based on the documentation and experimentation is that if you have RAM more than 1 GB, then you can usually start with 20 to 25% of RAM, given that this is a dedicated database server, and then you can gradually increase it depending on your workload patterns. But one important thing to make sure that usually going beyond 40% won't give you additional benefits. And what we have seen in production is that going beyond this usually returns an out of memory kill. So this should be stayed between 20 to 40%. And it is also important to remember that because this is a postmaster level parameter, if you are going to make any changes for this parameter, you'll have to require a server restart because the memory for shared buffer, it is allocated at the startup. So you will need to